Hey there. Are you designing plastic parts for a medical device or thinking about it? There are 5 mistakes that I see over and over and over again. The worst part is they're not obvious. A lot of times they won't show up until you're ready for tooling. Hi, I'm Pat Fanning, and I run Legacy Design and Development. We specialize in the engineering of plastic parts for medical devices, well, really injection molding in general. And I'm going to break down these 5 mistakes for you, tell you why they matter and how we can fix them. So here we go. A quick note before we start. Like I said, I specialize in injection molding for plastics. I'm just focusing on medical device components because the stakes are higher, there's biocompatibility issues, and worst case scenario, we've got patient concerns. So now let's jump in. Mistake number 1, and I see this more than anything, inconsistent or incorrect wall thickness. The material likes to have a nominal wall section throughout the entire part. And what I mean by that is the wall section is the same thickness no matter where you are in the part. This ensures that we get proper cooling, proper shrink rate, and consistent part performance throughout the entire design. So what's the fix? Ideally, we want to keep that wall section between 1.5 millimeters to 3 millimeters. If you need a thicker area or you need to improve strength, try using a gusset or a fillet. That way we maintain that structural integrity, but we're not adding mass to the part unneedingly. This helps control cooling and shrink rate in the part. Mistake number 2, and this is probably the second most common one I see, draft angle. Draft angle is that angle that we apply to the vertical surfaces of a part. This allows the part to be removed cleanly from the mold upon mold open or rejection. Ideally, we'd have between 1 to 2 degrees, depending on part geometry and location. If your part is textured, you might need to add more, maybe 3 to 5 degrees, depending on the amount of texture or type of texture you're adding to your part. Typically, a key sign that you need to add draft is you'll see drag marks or the part deforms upon ejection. These are key indicators that you don't have proper draft on your part. So again, the fix. What do we do about this? We use our CAD software to verify that we are, in fact, including 1 to 2 degrees of draft, or 3 to 5 depending on if we need texture. Most CAD softwares offer this. If you need to, you can reach out to your molding partner and they can do a draft analysis for you as well. Mistake number 3, choosing the wrong plastic. A lot of engineers default to ABS or polypropylene because they're familiar with it and it's typically cheap and easy to mold. But medical device sometimes relies on heavily engineered and critical materials. And a lot of times these have biodegradable or in human use pedigrees that are different from those you find in consumer products. We need to ensure that the material that we've selected for our product meets the ISO standard 10993, can withstand up to multiple sterilization rounds in gamma, ETO, or steam sterilization, and that we have the proper documentation to support the claims that we're making. So what's the fix? We work with our material suppliers in the very beginning of our product. We let them know some of the critical concerns or the critical use applications that we see our product being used in. We leverage their knowledge to help us pick the correct material for the application. Mistake number 4, incorrect gate location. It's been my experience that some designers don't know how to properly plan for the material to enter their part. A lot of times they think that is the molder's decision. We should be working with our molders to pick the best location for our gate because we know best how our product is going to be used. The gate location can affect the way the part fills, our shrink rate, do we see any warping, where flow lines might appear, but every part has to have a gate, so we need to be thinking about this from the beginning. Reach out to your molding partner and ask them to review your geometry. See where they think they want to put the gate based on the part geometry we have. If that gate location is in a critical seal surface or a highly cosmetic face, it's best to know that now so that we can plan to get that location revised so that we don't have that as an issue in production. This 30-minute conversation now will save us months of rework on the other side. Mistake number 5, designing to machined tolerances. I see more often than not that engineers get caught up in designing injection molded products to a machine tolerance, or they're converting from a machined plastic part to an injection molding part and the tolerance hasn't been updated. In injection molding, we see shrinkage, warp, twisting. This is all normal aspects of plastic injection molding, but it does come into play and change the tolerance stack-ups that we can hold. There are published standards that you can reference. Reach out to your molding partner and ask them to review your part geometry, review the drawings that you have, and ask them to provide you an audit report of your tolerance stack-up. In medical device, fit and function isn't just a quality concern, it's a safety issue. If the parts we're designing don't seal or don't assemble properly or fall apart in the field, that's a major quality concern. So what's the fix on this? Like I said, reach out to your molding partner and ask them to do a quality audit on your drawing and your geometry. Ensure that you're designing to the proper injection molding standards. That way we don't see these issues once we get into manufacturing and in the field when your product is being used. So to recap, the 5 mistakes I see all the time. Inconsistent or incorrect wall thickness, no draft or poor draft, wrong material selection, improper gate location, designing to the wrong tolerance. The good news is that all 5 of these are really preventable. We just need to catch them soon enough. And that's what this channel is about. Helping product designers and engineers avoid these pitfalls that I have seen play out over and over again. If this was helpful, hit subscribe. And if you've got a question, leave it in the comment below. I read all of them, and you never know, your question might be the next episode. I appreciate the visit. I'll see you on the next one.